Anybody still have a standard transmission in here?
You have an old.
Couple of you?
Yeah.
Three, four, five, nice.
That's fun.
I'm currently driving the only vehicle I've ever owned that isn't a standard. My old one, my favorite rig I've ever owned in my life. Every time I hit reverse, I go. Right? And it was like that for 28 years I drove that rig. Okay. Well, what was happening there?
Did you synchronize it for going out?
Slop.
You didn't know how to drive.
No,
Just
I
kidding.
was having a fit that interfered, right? And so I'm wearing those parts out as they're meshing. And the truck had some good stuff because it did it for 28 years. And I never did get that to where it fit. But certainly I think you see you've driven old rigs where, you know, might have started that way, after 10 years it now slides in, and then eventually you don't even need a clutch, it just goes. And that's where you're wearing those parts out. And that's kind of the ramifications of why we do this stuff. Because keep in mind, I can have a very tight fit on here at MMC, where there's going to be no vibration going on. This same parts can also have a lot of vibration based on the tolerancing that was defined in the manufacturing process. Yes, Lisa?
So if you have a bad machinist and you give them this and they make it wrong, it doesn't fit, are they gonna mad at you or are they gonna, who's in trouble?
If it doesn't fit, the part is trash, thrown away.
Well, no, but if you give them these things and they make it so it doesn't fit, I mean, who's responsible?
Oh,
So who gave you the dimensions to drive?
Yeah,
Yes.
so if you give them these dimensions and they do the wrong one, they do the Elmsy, and it's like, and then they come and get your job? Or
generally no.
Okay.
Drafters are kind of insulated from that.
Okay.
We have those design professionals, especially when you are straight out of college, where you'll be working under the purview of an engineer, architect, one of these people that are licensed to do this type of work. Whether it's consulting realm, you don't need licenses if you work in the private industry. It's only in the consulting realm. But these are the folks that are going to make the call. So generally, they would come in and say, why is this here? And you would just say, I don't know, go talk to
Someone's like, okay.
talk to Fred or Sally. They're the ones that gave me the sketch. Okay, or told me how this was going to work. You may not know the whole story, kind of like Angie said, she started with just correcting little bubbles, and then she went to brackets, and now she's been put on a project where she's doing an entire conveyor. So they're growing you in that process. But at the point in time, drafters are generally insulated from that because it's going to be one of these other people that are going to have to take that call. You just pass it on up the line.
Okay, cool.
As a general rule.
As you're drawing it, are you supposed to do the math and then attach a note that says, hey, this?
Generally, no. What I'm going over this for is so that you understand the tolerancing process. Now, this is probably what the designer has done. And that could be you, folks, but it's probably going to be a year or two down the road once you get into the work world.
The one that calculates the math all behind it.
Yeah, there's a lot of drafters that do this type of work. There's probably none right out of college to do. I'm sure Burley Pickett Equipment's got some cool stuff.
Oh yeah, they do.
Okay, they have what, one engineer on staff? And I think drafters do the majority of their work. The one engineer just kind of is an overseer. As a general rule, most of the drafters do it, but the drafters have been there a long time. And they know how these machines work through the School of Hard Knocks experience, right? Which is a very effective school. In fact, in my opinion, it's one of the best. So they've learned the process through time. They say, oh, hey, I know this has got to be here because the last time I did it different and that darn part wore out in 3 months. Hey, we had to change something. So you get that through experience or education, one of the two.
So as us as drafters, will we ever have to go out on like a job site, measure parts, and then have to draft them and then bring them back in, or is that the designer's job as well?
No, you would be doing that.
We would be doing that.
Yeah, you'd go out, do a tech sketch, or bring the part back in, measure it and go. Yeah, generally, we would do that. If we're just replacing them. If adjustments need to be made, we get the team involved.
Oh.
And really a good team environment would be design professional, would be a communicator like us, and it would hopefully have the construction folks involved too. Sometimes we can't get them involved, sometimes we can. I always had the better experience when I had the whole team. Because those construction folks, they bring a lot to the table. Anyway, this is telling you how the part is going to perform. Least material condition, maximum material condition. Really the one we pay attention to the most is the tightest fit, or allowance. Yes?
Does the tolerance vary on the material that's being used?
Yes?
So like, if you're using like stainless steel, would the tolerance change if you move to like something else, to a different material?
Mm-hmm. Yes, very well could. Yeah, it's mostly on those first three items we talked about before. Life, performance, safety. Okay? And whether it needs to interchange or not.
And would that just be based upon the friction between
And
the two?
that's going to come into material and the whole thing, yes. Yeah. So are we using carbon fiber because we're extremely hot? Are we using plastic because we want it to break? You know, what are we using it for? And all those things come into play when we're doing the design of some object. And you folks, you will be involved in the design process. How else are you going to get that experience to where you can start doing it on your own? All right, now, we've mostly talked just about general and direct tolerancing, but I want to make sure you see this. I see this on quite a few mechanical drawings. I've never really used this method in the work world, but I have seen other companies use it, and I like this method. It's a very useful method for cleaning your drawings up. And I'm on, let me give you a page number here.
844.
Yeah, 844. This is a direct tolerancing technique, but it goes with a table. And tables are always nice because we get stuff off of our drawings, and so our drawings read better. This would be a chart that sits over by your general notes. And what this is saying is UOS tolerance are as follows. And then you use decimal places on your dimensions. This is the only time you should ever deviate from having significant numbers differ on a drawing. The only time. And what this is saying is, if I have 1 decimal dimension on my drawing, so I take a part, and I've got it here, and I'm going to throw a dimension out here, and I use it, and I call it 1.0. Based on the number of significant figures, that will then apply a tolerance. They would go to this chart, and they'd say, oh, I got 1 decimal place, I'm plus or minus 0.02 inches. If this was dimensioned as 1.00, it has 2 decimal places, and this can be on the same drawing. They would use this one. Now it has been reduced to a 10th, or excuse me, 100. If it was dimensioned as 3, it would come to here. Now we're giving them 5 thousandths of tolerancing. Does that make sense?
Kind of. Would that be in the notes or by each?
Generally, you see it in title blocks. I've got a bunch in the mechanical folder back here, and you can see real examples of them. So feel free to look through those. But generally, you have your general notes, and right above that, or in your title block, you have a space for this. The companies I've seen that use this technique, they incorporate it into their title block. Now, we're talking the mechanical industry only. Because civil folks don't use this.
Yeah.
Architectural folks don't use this. Structural folks don't use this. It's the mechanical industry. But it is a real effective tolerancing technique where you're using the number of significant figures to define the tolerance of the part. And let me kind of maybe draw a better diagram and show you what I'm really talking about. So let's say I had something that looked like this. Look familiar?
Yeah.
Okay. So let's say I had something that, this is the view I'm using. Okay. Now I had that same chart, you've got your text up, I took it off the overhead, but if you had the same chart, let's say I come in here and I dimension this part at 6.0. And then I come in and I put this dimension in, and this will be 0.40. What am I telling them as I build that part? I'm telling them, when you make the width of this guy, you're gonna go, what is it, 0.02
Yeah.
on that chart? They have 200ths of error. So this can be 6.02 down to 5.98. When they come to get the width, or this part right here, or the thickness of the material, I went 2 decimal places. Okay. Gonna write, this is, but this was,
We got 0.01.
this is 0.02, right?
Right.
Right. So this is 6.02 down to 5.98. That's their acceptable sizes on this total width. Then I look at the thickness of the material. This one, what's this guy?
0.01.
0.01. This has to be 0.41, 0.40, or 0.39. Those are the only acceptable sizes. Yes.
So say you have multiple of those, but they're all different decimals or whatever. Do you give an overall dimension and they bury the slop wherever?
Oh yeah, they still have to bury the slop somewhere.
Huh.
You bet.
So would,
And really, you're gonna think of it this way, maybe all my location dimensions are done to 1 decimal place. Maybe all of my size dimensions are done to 2 decimal places. Whatever the case might be, on when I was designing this part.
Can you do that on one drawing? Can you get 2?
All I'm saying here is, you can pull those tolerances out, have a table, and use the significant figures to control the tolerance of the thing. And that's easier than coming in here and on this one, putting plus or minus 0.02, and then I've got another one, I gotta put it again, I've got another one, I gotta put it again.
yeah.
Okay, so all I'm doing is cleaning this thing up and putting it in a chart. A lot like the tabular dimensioning style at the start of the chapter.
And if they ask to find the MNCN of those two, we would choose the smallest one and one of the biggest ones.
Yeah, depending on whether we're a positive or a negative shape. Negative shapes would always be the smallest one, has the most mass. Positive shapes are always the bigger one.
Oh, okay.
So what if you, I guess my thing is when you're burying the slop and you add it all up, is there like a certain area, like a certain amount of numbers where you don't have to, or do you want to hit exactly 6?
You won't hit exactly 6, so we leave one part undimensioned. I think, let's get something on the
Yeah, I
screen
did-
here so
yeah,
we can
but
see it. So let's
were there
go to
different
figure
tolerances?
1716. Okay, this guy right here, 1716.
Yeah.
I think you're confusing the tolerance, the direct tolerance I'm applying to these dimensions to just dimensioning. Because tolerancing and dimensioning are different things.
Uh-huh.
So on this one, I'm burying all my air right here. Okay? Because I have this. Now this can be 40.0, this could be 50.00, have different tolerancing applied to a chart. Or I can come in here and I can say, you know what, I'm going to use direct dimensioning. This is 38, this is 41. And then I can use this as 50 plus or minus 1. Can I mix these up where I do limit and bilateral? Yes, you can. Can I do it with just a decimal point and then reference out to a chart?
Yeah.
Yes, I can do all of the above. Now, be a little, of course, we don't want to confuse the issue, right?
Yeah.
Okay, so would I ever do all 3 on the same drawing?
No.
Probably not. But they're all options for you. So keep in mind, when we're talking tolerancing, they're applied through 3 methods. General, in your general notes, applies to every dimension on the drawing. Direct You have two types on direct. You can use limit or bilateral. And then you have kind of a combination where I'm using significant figures with a table to control that, which is really a direct / general method. That's how you apply the tolerancing. That's what we're talking about. Got it? Think, maybe, yes, no? We'll get some practice on this.
Yeah.
It's not going to happen today. We got one more day of tolerancing that we're going to deal with the rest of this issue tomorrow, and then we'll start practicing. I do have something else I want you to look at, though. We get a little practice on this to make sure, because we aren't going to see this for the most part in the drawings we have. So I'm going to do them through a worksheet.
Oh, it's fun.
All right, so let me explain what we're doing here. All right, the first one, we haven't had a chance to really do this, so I want to look at it. So this is the tabular dimensioning style. I think it's on the 3rd page of chapter 17. Right in that zone. I might be plus or minus a page. How's that for a tolerance?
That's good.
So in essence, your origins is lower left corner. That's 0, 0. If you read the instructions on here, they ask you to locate these holes. You are using a decimal system. I would like your dimensions to the nearest 500ths. You're using decimal, not fractions. So don't use your architectural scale. In essence, you are basically locating all of these holes in this chart. This is a tabular dimensioning style. So in essence, we're pulling all those location dimensions out, putting them in a table. So here's 0, 0. You just basically measure your x value, which is of course this way. Y value is this way. They go in the appropriate column. Use your center lines to help you. Okay, this is the center line. Okay, so if I measure 3, do I now know 4 in the y direction? Yes. Round your answers to the nearest 500ths. Use your triangles to keep you straight. Okay? Now, use your triangles on this outside border. So you can set that down and then make sure you're measuring x instead of a slant. Okay. So stay accurate. Second page. I think on this top part, didn't I write don't do?
Yep.
Because we've got plenty of counterbores, countersinks that we're doing as part of drawing, so let's not waste our time with those. I would like you to do 2 at the bottom. Here, we have not had a chance yet to dimension a keyway and a key seat. So the only dimensions I need here, folks, are those that reference to the keyway and key seat. Feel free to look in your text for a little advice on these. Now, you're using fractional inches. Okay, this is not decimal, this is fraction inches. So when it says a 3/16 square key, keep in mind the key, what device is the key?
The little square.
That little rectangular piece that fits right in here and right here, right? So if it's a 3/16 square, what we're putting there is where this dimension is 3/16 and this dimension is 3/16. Half goes in each device, right? So use that to calculate your dimensions that are needed. All dimensions are fractional inches. Okay. Wait, hold on. Something popped into my mind. Can we stay with nominal sizes?
Can
What's half of 3/16?
we? Yeah.
3/32. 3/32 nominal size in here? No, it is not. Let's do a revision. Let's be flexible. Quarter inch, square key. Darn them odd numbers when you divide them. Use a quarter inch square.
Instead of 3/16?
Yep, or you're gonna have to go to 30 seconds, and I don't wanna go there.
Why? You don't want to do the math?
I'm not gonna build it.
True.
All right, just those two items, please, the tabular dimension style and the keyway key seat. Let's make those due,
End of day.
well, let's see, we have, yeah, we should be able to get these done today. They're not gonna take you forever. So let's go ahead and do those and get them turned in. I won't dock you if they wait till tomorrow, but I prefer them today. So let's make these due tomorrow. Although you're gonna have another worksheet tomorrow handed out. All right, so tomorrow we're gonna finish off chapter 17. Okay, so we'll go over the fits, which you're gonna like fits. It's basically designing off of the shoulders of others. You know, you've heard the expression, don't reinvent the wheel.
Mm-hmm.
Okay. That's what we're gonna do, is we're gonna look at how these parts have all worked together, they've got it all figured out, where's this information at, and how do we use it. Okay. All right, that's all I've got for today. Any questions? Thanks for your time. Have a productive day. My old man used to say, let's make some hay.
Thank you.